But the biggest change in the technology is conoscopic holography. And what that means is the laser hits the object and comes straight back and gets collected in the lens. Now, why is this important? If you have a big, deep tissue and you're using traditional scanning, which is triangulation, it won't allow it to come back out and retrieve that information. So what ends up happening is you get a round bottom where it could actually be square. And where that's really important is when you're designing your custom abutments. So we need to be able to scan right down that sulcus to make sure we're designing a nice contoured abutment. Basically, we have the 4 different product lines, which is alumina, zirconia, titanium, and the chrome cobalt. This is just giving an example of different alumina. It kind of has an aura around it. People used it, I think, improperly when it was first introduced. Nobel, I think, did a very poor job on educating the laboratories how to use it. But translucency, it has 72% translucency, where zirconia is quite low. And so we're actually seeing alumina, believe it or not, making a large comeback in the States for anterior cases. So it's still around and it's being used. Who's had loose copings from Procer? I'm sure probably most of you have. The best one I ever heard was socks on a rooster. I think that was the best way to describe it. The reason that is back in the days they used a point contact, which meant the only contact on that die was basically around the margins. So I mean that thing would turn, it was just sloppy. Now what they've done is they've actually gone to a broad contact. So they've actually have, I think it's 2 millimeters of contact now up the surface of the wall. So it gives you that nice tighter fit. Cement space is still the same, but the contact's a little bit different. So that's what it looks like on the computer. On the second one, you can actually increase for most of our products, except for zirconia, which will be coming pretty soon. You can actually increase or decrease the amount of contact. So if you have a doctor who really likes passive fit, you can bring that contact surface down to 1 millimeter if you want. And then you can also adjust it from a medium to a tight fit. So you can really customize your fit of your restorations. And that goes for all the materials. That's just a good example, cross-section, so you can see the contact zone and then the cement space. With our metals, we actually we mill this band in the metal, and you can actually see it on the model over there. You can check it out, but you can see on the picture on the right. So it's contacting pretty much right on the margin, and very little space, and then nice amount of space for the cement. Titanium. Titanium was introduced a couple months ago. We're actually working with Ken Parker and Vita to develop programs to train technicians how to use Vita or the Vita porcelain properly. There is quite a bit of skepticism when it comes to that. Usually it's because of what people have heard from Europe and the problems that they've had. The titanium that they were traditionally using and that people have used in the past has been cast titanium. To be able to cast it, you need quite a bit of different metals in there to make it smooth enough so you're not going to load it up with porosity. So the milled titanium is a lot easier to handle. It oxidizes evenly because the block is even. It's not cast, so you don't have what's the proper word, but a difference in metals when it's getting melted. So it's a very monolithic block. Here's just a couple examples of the size. So we can do up to, this is actually wrong, this is American. We can actually do up to 8 units splinted. So in the States it's 14, just Health Canada. But we're seeing some good success with it. But again, it's going to take a little bit more education and getting used to. Chrome cobalt. I know it shows the misfit, but that's actually not really what I'm worried about. This is just a side-by-side comparison to one of our competitors. And the biggest difference that I want to show you is just the connector. The connectors are very rough. Their mills have a tough time getting in those small spaces to give you a nice smooth connector, which, as you know, can give you some problems with the porcelain. Whereas our mills are true 5-axis, so they can get a nice even connector. This is Stefan Holtz, a guy, a doctor in Germany. This is a case he did. He's doing a metal try in there, and I don't know if you can see it well from the back, but there's just little connectors. When you get it back from production from us, that's all you have to clean off is those little connectors, and you can go straight to fire. Chrome cobalt, that was introduced last week. Some huge interest. I've been getting calls left and right saying, "Hey, what can I do with chrome? Like, what's going on?" The biggest thing to remember is VM14, correct?
13.
13. VM13 works with it, so it's the same as your semi-precious alloys. So you don't have to learn any new techniques. You don't have to learn different firing cycles. It's very similar to what you'd be using. It's also biocompatible, which is kind of an interesting topic. They've taken out the, I think it's listed here, I always forget the name of them, but nickel, no, it's not on there. Nickel, beryllium, and iron, so it's all three of those free. But that's the first question the doctor's going to ask you, is there any nickel in it? I've gone to so many doctors and I said, hey, would you like to try a chrome cobalt crown? And they go, ha, no way. And you're like, why is that? Well, there's nickel in it. Well, what if you could get it without the nickel? And they start to go, this is kind of a cool idea. And then the other benefits too is you start talking about fixed price. So if he's quoting a patient for 8 units, that price stays the same from January to December because the laboratory has a fixed price because there's no fluctuation in the price of chrome cobalt. So it's a very nice alternative, and that's why the two metals, titanium and porcelain, are becoming more popular. So, Telio, we launched that actually Monday. It's a temporary crown milled out of our facility in New Jersey, 5-axis. This is actually straight off the mill, this image. So very little finishing. It's 130 megapascals, so it's a very strong temporary. It's indicated actually for long term, so up to a year. Are you going to be making this for your everyday single temporaries? Probably not. But for your full arch cases, your bigger aesthetic cases, you'll probably want to use something like this. That way the doctor can contour tissues with it. He can actually add on to it with his own acrylic. So there's a lot of advantages of that. And there it's finished. Again, we can do up to 6 units and 6 different shades as well. So there's a picture of it in the middle. I think that's an ugly picture, but that's all I have. There's a cross-section view of the fit. So it's very similar to the milling that we do for all our other PMRs. So same type of band for retention and cement space. Custom abutments. I touched a little bit on it, but this for Nobel is probably our biggest growing single item we have right now. It's with our new 5-axis abutments, we're getting some pretty nice results. There's some examples over there. But something to keep in mind is if the top of the implant, this is our new kind of limitations. Before it was 35 degrees, which I'm sure you've all seen. Your abutments, they turn out well, but whenever you need more than 35, you can't get it. So you have to go to a gold adapt, which is going to cost you quite a bit more money, time, and it's just an overall pain. With our new mills, we can actually go 5 millimeters straight out of the implant head and 15 millimeters straight up. So that's why that one with the gold crown was so important, because they brought the margins right out and then brought them up, instead of just having this little tiny abutment. Now, Jay, Tim are experts on this by now, and it's amazing what you can do. You can see, you scan in the tissue, and you basically form that abutment right to the tissue. Your doctors can say, hey, I want a little bit of a little pressure on that tissue, so you can pull it through the tissue to give it some pressure. So it's very user-friendly, and you're gonna get back what you designed, which is the most important thing, without that extra cost. Again, all the Noble Active are available in shades now, so that'll help with your whitening below tissue level. So Astra, again, we've already touched on this, but we can do the Straumann, the 4.8, and the 6.5, that's the Sonata, and the Astra, the Lilac Yellow Aquas, and the Ball Metals. There's some examples over there. So here's just a couple of screenshots of the actual software. So they can either design the abutment using just CAD, where they're basically freehanding it. They scan in the byte registration, and they basically design it from within those parameters of chase of teeth and byte reg. Or what they can also do is they can bring in a crown from the tooth library and design it within those parameters as well. Both would work fine. Screw retained. For now, what happens if you need a screw retained bridge or restoration, you need to wax it up. And when I say wax up, I actually mean the best way to do it is basically take 2 temporary titanium cylinders, join them with acrylic, and then do your wax up from there. And the reason being is you want that nice and stable, because we have to actually scan that acrylic mock-up right now. if you, later on in the future though, we'll be able to just scan the model and then digitally design the whole thing. So that'll become easier. Again, there it is in the mouth. Advantages, cost being a very large one, because you don't have to purchase 2 abutments. It's the titanium, just like the titanium crown and bridge, it's radiolucent, so you can actually x-ray through it. And this just shows exactly, you can see the screw right in the implant. So the doctors, when they're doing a titanium case, they can actually x-ray through that crown and see if there's any issues underneath. So that's another huge benefit that they're really liking. Overdenture bars. The Nobel bought a company about 2 years ago now, called Biocare, and they've basically been developing the bar market. It's pretty much growing about 20% a month. Almost. It's exploding. Main reason being is the time it takes to create that bar. I'm just going to skip through this. So this is just there's a handout of this if you want to grab it. These are the fixed bars. So fixed being something that is screwed in the mouth of the bar. You want to make what's called a verification jig. And I know our doctors take perfect impressions, so we never have to worry about that. But what you want to do is you want to get titanium temporary cylinders, join them with acrylic, make sure it's nice and stable, send it back to the doctor, and get them to do a try-in and screw it in. And if that acrylic breaks, that's okay, that's fine. We want that to break, we don't want it to flex. So Duralate, something that is a pretty common thing in the lab, you don't want to use because Duralate will actually change a little bit with temperature increases and decreases. So if you're shipping it somewhere, it's going to move around. So you want to use a good acrylic. Get the doctor to screw it in and take an x-ray. So I think I've had 1 bar in the last year where it didn't fit. And first question I said, do you do a verification jig? And he goes, no, I never have to do that with this doctor because his impressions are perfect all the time. Well, sorry, can't help you out there. So it's very important that you need to take that verification jig. Once you've done that and you verified the model is the same, then it's warranty. So cases is almost the same price as the finished bar itself. Wax it up, invest it, cast it, polish it, solder it, most likely. Now, obviously a lot more labor, cost-wise, it's going to be quite a bit more, especially if you use any semi-precious metals. Another benefit, or I should say, something that we're seeing now is wax printing. I'm sure you've all heard of it. And I have all these people asking me, what about wax printing? And I say, yeah, it's awesome, it's great. The mold comes out, the wax comes out, and it looks great. It fits the model perfectly. But realistically, in your lab, where is the problem? Is it the waxing, or is it the investing? Here's our bar, and then our locator, and then this is the denture. So you can see that we're too close. So the person designing this bar would want to move that. So all those problems and issues, you can pretty much get rid of in the CAD-CAM. A couple examples. We can do bars on, it's over, I think we broke the 260 mark now. So 260 different implant companies is what we can produce bars on. We have I didn't put it out there, but we just had a lab send in a case for 12 implants, a bar on 12. So that's the most they've produced. I've seen, this is a side note, but it was implants in the 7s a couple weeks ago. So 1 per 2 guided. So kind of interesting. A couple examples. This would be a fixed bar. So these are retention elements, and they would bake acrylic grid on top. That's actually a Strawman case. And it comes polished as well. So all the bars are coming polished, so you don't have to do any of that. Again, a milled bar, so you kind of see our kind of limits are 30 degrees. So if you have 2 abutments that are 30 degrees or more in the opposite direction, you can't do it. You're going to need a multi-unit or something to correct that angle. But they've done some pretty gnarly stuff. I have even worse pictures than that. Big leaders of the kind of up-and-coming materials. Noritake, that's going to come in a little bit later. They're developing some pretty unique things right now. So right now we're actually not even using any Noritake products, but we are working with them. That's it. Any questions on any of that stuff? Everybody wants to go and eat that stuff. All right, thanks a lot, guys. And thanks, Jay.